You got that. You want me to do that? Oh, we're done doing that. Whoa. Hey, man. Just go, man. You got work done today, dude. That's cool. I'm glad. That was my heart. Let's have more of those. Have a good day, man. Perhaps I didn't do all my antennas. And I got papers for you. Papers? You must have papers? Just take your paper. Here you go. Wait a minute, you got lots of stuff. It won't open. It's not my fault. I didn't do anything. That was that look. No, that was the look you were giving me. Like I didn't do anything. That's your problem, man. Wait, I need one of these. Can I need one of these? I will dispose of your liner. Or regular. I'll go down to liner. Here you go. You get one of these?
Thank you.
And you get one of these?
Oh, sweet.
Lucky.
I know. I feel pretty blessed here. Wait.
Dude, I did the pants today. That's special. Here you go.
Oh, I got two.
I can't tell you. I have two pair that I just got for Christmas that kind of look like that. You know, they're like pajama pants, right? Yeah. I want to wear them all the time. I get home, I change clothes like within 5 minutes now and put those things on.
Sorry, I'm very easy with trivia practice.
Which one? You're there. You're here. You're there.
You know, I think I'm gonna take the cool chair today.
Oh.
Wesley's not here. Plus, I don't really know how I feel about everyone staring at my back for a couple hours.
Wesley is kind of here.
Is he watching? Is he on live?
I have no idea.
If we wave, can you see all the people that? Can you even? It's just random people. Maybe there's random people on there.
There could be random internet people out there.
Hi, random internet people. I'm not gonna tell you my name.
Swear and stuff.
You can't swear today. Darn.
Well, you can. But within five
In our head.
I picked all the wrong names. All the wrong names. The piece of paper you have in your hand on the other side.
It got destroyed.
Which city you got, Tree?
Destroyed. Wasn't it in Nevaeh?
Sodom or Gomorrah?
Oh, yes.
Sodom and Gomorrah?
It was just Sodom. That was the answer. Oh, wait, another history question. What is the name of the plague that was considered to be one of the most deadliest?
Black Death or the bubonic plague?
Bubonic plague. Yes. I'm about to win. I'm sorry.
You keep going. I'll into it.
Oh, we need a calculator. It's okay. ads.
Anybody eat food here? I got two. I'm gonna eat one. Got one, need one, got one. Need one, got one.
I got one. It's 3.
Need one, got one. Good. Thanks. Max?
Which country does this flag belong to?
That's, Belgium.
I was trying to. I have it.
Okay.
My bad, I have it. It was fine. I already did. It was in
What's
my
the
email.
question?
What is it called?
That's a blood pressure thing. It's called
How does it go?
Your kicking is rare now, right?
Okay, wait, what are you better at? Geography, sports, or
Oh, God.
history?
It doesn't matter. What do you like better?
Okay, so that's what is it?
Angora is best known for. Angora is the really soft, fluffy hair thing that they have on.
Have you longer? Oh, I forgot about notes. What do you mean 2 notes? Why? Josh talking about that's right.
Are you kidding?
Yeah, now I am. What sport in the Olympic others?
Most gold medals for the U.S. That's tough because they dominated in basketball. They've won more than anybody else. In terms of the most, because they've won more swimming ones, but they dominated in basketball. But there's more swimming ones available every year. Okay.
I know, I only have 2 classes. Well, every week, what is the name of
ZipRitter. Abraham ZipRitter.
online? Yeah. So nice. I get to do it whenever I want, or, yeah.
I get it all.
Do it whenever I want.
I'm a teacher. Did you know teachers know everything?
Electives too.
Academic, what animal is used for a river that meanders? What animal term?
Yeah, I can't use my, which is fine. Jenna, I'm about to win Kyla. Do it. I have one little person left. This is my best subject. So I'm taking nutrition. You can use nutrition.
All right, you start in Fred things.
Nutrition. Yeah. I need to go. I have 1 crown. Yes, this is it. Interesting, right? This is it. So I'm taking nutrition and taking like a health and
2013?
so we'll be.
Oh, it's either,
I went to Canada.
it's Canada, Switzerland, or Norway. It's one of those. I'd go Canada.
That's what I'm saying. It's fine. I mean, not like that's. I totally won all, but I'm like, how can I not?
Hey, folks, okay, so paperwork for today, you got in front of you? You have a slide that says normal curve warm-up. What you want to do is try the normal curve warm-up, see if you can do this on your own some. When you think you got it, call me over, I'll tell you if it's good, and then you can flip to the other side and practice the questions over here about King Grady and Queen Tenley. They're not even here, so whatever.
Maybe there.
They're fun. There's always Sergeant Arminings in here. Who else made this one? Let's see. Andrew's in here. Dirky's in here. I wonder if Dirkenheimer's here today.
McGrew's here, so probably.
He's been coming. Yeah? That's not his real name though. It's Dirkenstein. Yeah. Dirkenator. Dirk Muhammad. Sometimes standard deviations is 58 corners. What's that? Yes. Yep. So also in here it says, we're looking for z-scores. What is a z-score? I'll give you a hint. This is a z-score of 0. This is a z-score of 0, negative 3. This is a z-score of 3. What are z-scores? They're from the blanks. You are from the blank. This is 2 of them. What is that? That's 1 1. There's a special name. Starts with an S. It's a standard deviation from the.
Oh.
Yes.
Is this right? I feel like I'm missing something. I haven't done that before yet. I feel like I'm-
Yes, that's.
Yeah.
Do this.
Yeah. I really don't.
You can actually fill it in.
That's
one. All those in the middle there.
But,
What is this here? This. This one.
Yeah. I know, I do feel a little bit far away. Because I wanted the cool chair.
You can switch chairs.
I mean, I don't really care. My hair looks kind of good today. But I wanted the cool chair.
Not to like 2 pounds.
You know what I mean? Hey, Neil, what'd you get for number 4?
How many standard deviations are away from?
From the.
What?
Zero. What is this number called? Right here. Nice being. Are you golden? Rock star. You're good to go. See if you can use your calculator to do these guys. Okay. What's up? You heard me. Perfect. See if you can use your calculator to do those.
You do check.
I'll be right there. We gotta use your calculator on this, guys. 6. How many variations are from the mean? Perfect. You can use your calculator to do those.
Okay, can I go to the restroom first?
I guess. I can go too. You both me.
I mean, I can try.
Sure. So, the average. Perfect. You can use your calculator to do these guys right here.
Can I check?
Yes. Here you go. Yeah, see if you can use your calculator, number 1. Can you turn these 4 into percents? Percents is easy. As soon as you get some number 1 on the backside, we're ready. Let me know. Let me just write. First formal problems. This is such an appropriate problem to work on. Now that Megan and Harry have come clean about all their issues about being super freaking rich. I can't believe that. That just drives me bananas that they're whining. publicly.
I didn't see this line.
They're so ungodly wealthy. They don't have to go talk to the media. They could just go away. They could just leave. Go anywhere on the planet that you want and have the freedom to just be. Yes, they will. It only gets worse when they draw more attention to themselves. They can totally just leave and then be more.
And they already got out of it. If it was that bad, they already got out of it. Yeah, I watched this. I watched the whole thing with Oprah.
They lack. There's something that their grandma has that they'll never have. She has chosen to live a life of servitude. Okay? That's because she has chosen to live a life of servitude. That means she has lived her entire life in service. That's it. You know, I think Elizabeth II was a pretty great woman. She's not been selfish in any way, ever. And she just lived a life of servitude for her country.
Not really Henry's
Yeah, Charles has issues. Charles has always had major issues. Yes. What's up? This one is going to be the inverse norm one here. This one's going to be a normal TDF. You get the notes from yesterday? You get your notes, I'll show you. You're going to need them today because we're going to need the other page.
I'm just saying, I just don't have any.
Yeah. That's right.
I think I like using the yellow sheet better than the calculator.
The yellow sheet?
Yeah.
We're using the calculator. Is what we're looking for. There we go. Right there on the top, these guys. Okay. Almost TDF, and then 0%. Inverse norm. Yep, that's the one. Straight there. You can tell me, I got more in the yellow paper if you want.
I do have one. I still have one.
You could probably use it. It'll take longer.
I know.
Once you get used to it with the calculator, it'll go way faster. What's that? Okay, so we're just trying to figure out if I can draw a picture here somewhere. Okay, it's right here. Okay. This is a z-squared of 0. Where's negative 1.7? It's somewhere over here, right? 1.27. We're asking you what percentage should it in right there. Okay, so that means you're going from negative infinity is the lower, this number right here is the upper. So your upper is negative 1.27. What's the lower? How many standard deviations down below it do you want to go? What's the lower? 6 is the lower, negative 6, right? So negative 6, negative 10, negative 20, negative anything because it goes up towards infinity, right? Mm-hmm. And then your upper is negative 1.27. Paste it in here. Let's do 0 and 1 because they're these scores. Yeah, leave that all 0 and 1. Go to, get the 2, get 2, get 2, get 2. Oh, you used the line, you gotta use a negative. Right. So, but you have to hit that negative right there. You can't do minus if you're getting negative 6. Does that make sense? If you can't subtract 6, you gotta use negative 6. It's treats. This is subtract and that is a negative. How are we doing? That's right. That one's right. Okay. Yeah, start. Your inverse now. Okay, you got to change the meters because you're talking about these scores. You got to change back to 0 and 1. So when you're looking at those two, that should be 0 and 1. You left them there for a previous problem. Remember, I was telling you how to change it there. So that's 0, and that's 1. Now it looks 0.915 is a correct answer. Z-score 0 versus Z-score of negative 1.279. We're looking for this percentile. You're asking what is this shading? When you go to normal CDF, so you remember normal CDF? Okay, the lower is negative infinity. How many standard deviations over is how far I have to go? Well, you don't have it. I mean, this is like -1, -2, -3, -4, -5, -6. Your time totally different. Okay? And then your upper is this. And make sure you get those 0 and 1 for your variation for what you're doing with these courses. If you're using these courses. Yeah, if you decide to change that 0 and 1, you start doing other stuff down here, then you're going to change it back.
So this was still be 0.
Yeah, all of these are going to be 0.
You know, when I go and this two,
And like that. That's correct answer. Yeah. What, yeah. 0.10% of this 10%. I think 10%. I think you're definitely more close there. Yeah. That first one right there, 10.2. That's correct. Oh, 0.82. Because again, put your percentage has one as a decimal. It doesn't have a percent sign. That's correct. Oh, this is the wrong page. We're assessing normality today. Pretty important question. Actually, feeling normal today.
Wednesday, my home was full of last night and I had trouble sleeping.
So you're not feeling normal. You're feeling abnormal. You're feeling skewed. I'm skewed towards too little sleep. Where my door closed. Yeah, my door closed. All right. Hey, man. How you doing? Perfect, perfect, perfect. And that answer right there? I know.
Remember, it's normally 0, 1 or the.
Definitely 0, 1. That's correct. Everything you have right there is perfect. Put it into the paste and it's because you're stuck on the left. You got to arrow down once. Oh, great answer. Yes. That's correct. Are you showing me what you typed in there? 40%. So you're going to get 2%. That's great. The Julie Ann was one of the problems though.
Yeah, not the.
Not the, oh my God. Okay.
They're promoting our training.
For this guy.
So,
So, okay, no, that's, yeah, that is definitely the upper, because it's a percent up to that, so that particular one, if I said 2.55, it would be way over here, right? It's always going to be the upper, if you're talking about a percentile, because 0 to whatever, right? Well, that's why I use like -10 for IC score at the bottom and 2.55 at the top end. You okay?
I have a question. How do you?
On this particular one? Okay, so this one, the second dragon is bright red. And then it's blossom, green, nose and green. As soon as Penny turns around and finger puking Chester. All right, Sergeant at Arms Alyssa. She's right over there. Sergeant at Arms Alyssa. These guys are king. Who's labeled as being the 28th percentile. Where's the 20th percentile? Wait, 20th percentile? Where's the 50th percentile? That's the 50th. 28th is going to be somewhere over here. We're starting with a probability down here. We're going to go backwards to get the last score. Does that make sense? So you're starting with this number, then you're going to turn it to a z-score and use the z-score to cover off.
So it's 28%.
Yes. So that problem you're working on right there is very similar to this problem right here. So you started with the percents and you worked your way up to here. Or the same as this one. Yeah, percent to z, and then you have to use the equation to get the rest of it. Did you find yourself in there yet? Well, you'll get to it. You have an important job.
When I started doing this,
She has an important job. Did you find her in?
yeah,
This one.
she does not prove that green is
Wait, does that say 30/90 or 30/40? Your equation right there? No, it's totally right. Your equation is perfect.
You gotta know that.
I think you were.
No, nothing. You got it.
You added 3500. You should have added
34, yeah.
There you go. Did I check in on it? That's right. Yep, I'm check. Or you're not sure, let me know. Okay. That's the right answer. Perfect so far. On this one, you're gonna have to use the equation to calculate and do it for you. Because you're gonna be given a bunch of information, you're trying to find out. You're given a z-score or something, you're trying to find the
What was the?
standard deviation. It's not, it's the same. That right there. It's not -5.8. I think you're, if that's not -5.8. You got the right one here, you wrote it down wrong.
Oh, I'm not looking over the.
That's not wrong with these scores. You're taking a percentile.
Okay.
Number 6. This one is a lot like. We did one really similar to that right over here, where you started with a percent. You start with a percent and you go backwards. So that's in the chart. You're starting down here. Where is the 28%? Where's the 20%? Median, that's the 50th percentile. I put 0.5 right there. Somewhere over here. 0.2. And this dragon, we're trying to go backwards and we're trying to find. That way, you're gonna have to get a z-score first, and then use the z-score to get that using this equation. Did you get equation number? This is a good dip for next right there. Solve for x, it's now the row. Ooh, algebra. Ooh. Okay. 20th percentile. Which one of these is percentile? Is that or that percentile? It's down on the bottom. Erase that 28. Okay, this is 0 percentile. This is 50 percentile. This is 100 percentile. If this is 50, somewhere over here, right? Right in there. Wait. What you have to do is you have to go backwards. You're going to go from there to there, you get a z-score, and then after you have the z-score, you can go there to there using this equation. But you're going to need the z-score first. You know how to turn percentile into a z-score? Oh, I did that up here. What'd you get? Okay, this is a really good equation. You should be doing that times that and then that. Okay. Do you get a z-score? That is the correct z-score. That goes in that box right there. That's immediate. That is the z-score there. Now that you know the z-score, you have enough information to use this equation. Okay. How we doing, boss? Pretty good. That's perfect.
I think I'm done.
We don't mind. That's correct, yes. I think so, 32, 40. Oh my gosh, that's pretty good. They got what that is.
It's pretty cool.
Yeah.
Only for like free fire.
What's that?
Only for free fire.
So what kind of job would you have if you were a royalty? Would you be like the lady in waiting? Would you be the queen?
I probably want to heal off this instead. That's not.
So
Might come for 10 minutes.
you'd be good about it, the queen. Queen lady. It works.
I'd say.
Yeah, the guy who plays the queen in the Netflix show, her name is Olivia, the actress.
What show?
The second one. No, the second one or the third one? She's the second one. In Netflix, the Netflix show about the royals, it's called The Crown.
I haven't seen it. The only royal show I think I've seen is the new one, Bridgerton. And that one is like,
Royals are just rich.
yeah, I guess you're right.
Yeah.
Well, he's a prince or something like that. Or he's a duke.
Duke, or whatever. Yeah.
I guess it doesn't really count.
Oh, big brain on you. The only reason that yours is 3 different than mine is I rounded my decimal here different than you. But your math is good. You're doing the right thing.
So what do you want me to do? Like, how do I know when to?
Round where you want. As long as this thing looks like an equal sign, and mine looks like a wavy one. As long as you throw a wavy one in there, you can round where you want, because you're not saying it's exactly equal, you're saying it's about. Okay. So equation is great. I'm gonna do the typing in here. There it is. Negative 0.3 times 700 is correct. And you add a negative, you just want to add 3450.
Mine.
Let me show you this. This is a smaller number.
Yeah. Because your eyes are squinted. More.
Over 10 equals 2.
No, I'm funny.
What would you do
That
first?
I'm funny?
No.
Over 2.
Two of those.
Here you get plus 3, right? What goes in the box? 1 is equal to something plus 3. Totally 17.
what do I do over here? What operation do this? Subtract 3, right? Because that's the opposite. What is the opposite of subtract 3450? Add 3450. You add it negative 3450. You just want to add 3450. Do that, you'll get it right. Okay. Next. Oh, let's see. We don't have time. That's correct. You're putting it down here on the bottom, maybe? I think that looks pretty good. 2.326. Yep, that looks good. Okay, this is the right z-score, okay, but it doesn't mean much blossom wings. What you've done is, this is the 0, and that's 0.5, 0.28 is somewhere over here, right? You fill the red box, that's negative 0.58. We're trying to find the weight. What is the actual weight of this dragon? You go there, you still have to do that. Use this equation. I know the z-score, I know the mean, I know the standard deviation. Really big. Yep. Okay. You see that yours. Sorry, that's permission. Not cool. Teachers should be writing on your papers unless they have. Some people flip out.
Please, do you want that?
I've seriously had students flip out on me. Like, not a few of them, a bunch of them.
Crazy.
So, yeah. How we doing on time? We're out of here at 10.
We have extra time today? Or
We
no,
find
yesterday?
not yesterday. Today, we don't have much to do. We gotta make sure we get through it. We have to assess whether or not you're normal.
Mhm.
Are you normal?
No. What is normal? Normal's boring.
Well, in mathematics, that's the normal curve. Lots of things fit the normal curve. So we're gonna make the normal curve up here. We're gonna do that next week. Okay. I was hoping we'd have time to do this, but we're gonna have to turn into some sort of like assembly line. And you'll get to see what happens when you sample things. Sampling is a big deal in statistics because collecting censuses all the time is crazy. Census means you collect out on everybody, you know? So like, if I wanted to know the average height of a 12-year-old in the country, in the United States, would I collect the data on every single 12-year-old in the entire country? That's like impossible. Can you really do that?
I just think normalize it.
Time, energy, finances to do that. It's just not possible. So what do? We sample. We try to sample well. We try to get random samples, different places, make sure everybody's eligible to get picked. So we sample random. But when you do sample, what happens with data? There's something really special that happens when you sample data, as opposed to just looking at the data. It has to do with that. Right, did I get everybody checked? Are we good to go? Ma'am, are you good to go? You the last one checked? No? That's all out of yours, I saw. Last one, really big dragon, yes. This is a good equation, and that is a correct answer. How you doing? That was perfect. I would say it's close to perfect. The reason that's a 74 and that's a 78 is you learned it in chart. It's up. So that's the other thing was really good by the 80.
No, it's like a different game.
Start rounding. It's not really equal.
It's box wood.
Box boy, you're playing box boy.
It was my sister's calculator. Let me take off.
Your 2.32 is correct. Yeah, everything else is there. You're totally right.
What goes electronics?
Oh,
Genius.
didn't he like do a whole bunch of people's?
Oh, yeah. I stopped by your spot, maybe we should.
I have just the like.
Smart dude. Purpose.
He's a sophomore.
Sophomore, and he's like,
He's an evil genius
I
child.
like to call it genius, but every time I see him, I'm like.
I've had- So I've been here 28 years now. I've had some scary smart students. One of them is actually still here. And she doesn't really want to know about school. We have a kid here who's just like, crazy. Ooh. Yes.
Say smart girl, and then they come to mind.
She did something that I've never seen. She basically took the math test and she aced like the first 80 questions or whatever it was, 38 questions she aced. And it asked her a lot of stuff that she didn't know. She just figured it out. I mean, the highest math score I've ever seen.
Once you go restart funding.
She's like the nicest person.
I always tell people, her mother was the best athlete I think we ever had. Boy, girl, regardless. So Mrs. plays the only book. I think she's the greatest athlete in Meridian High School history. And the thing that made her the best athlete, it wasn't that she was just athletic. She worked 10 times harder than everybody did. So she was an amazing volleyball player. And she was an amazing basketball player. And then she blew her knee out both her junior and her senior year. She scored 1,000. Get this, her first game as a freshman. Game number 1 as a freshman in basketball. She scored 32 points. In one game, first game, freshman started varsity, 32 points. Never did it again. Because she didn't have to. They were a good team, so she didn't score all the points. She had other people on the team who were dynamite too. So. Yeah. When she was a junior, we got to the Final Four at state. And she blew her knee, was out. And our second leading scorer blew her knee, she was out. We still made it to the Final Four without our best two players. We would have just rolled through the state tournament. We were easy state champion then. That's so. She's fantastic at it. She's the best. In terms of smart kids, I had one boy named Stephen Madison that was scary, intelligent. Like the movie Good Will Hunting. You guys know Good Will Hunting?
Oh, yes.
You know that one where he reads, he's like, why would I pay for a $80,000 a year education at Oxford when I can go to the library and get the same education for free?
Yeah.
Because he just picks up a book and he reads it and he understands it. He's done. Why would you pay for that, right? So I had a kid like that, his name was Stephen Madison. It was the very first year I taught AP calculus. There's an AP test and what's called a BC test, which is a harder test. And I told everybody, it's like, I'm going to teach to the AP test. I can't help you with the BC one. You're on your own. He's like, okay, I'll do it. But he says, I just got to know what parts of the book are going to be on the test, on the AP test. So I told him what chapters. He goes, good, thanks. We never talked about it again. He never asked me a question. He never did any practice problems. He didn't do anything except read the book. One time, and he aced the test. I couldn't do it. There's no way. He just read the book and he understood everything and he took the test. And I know he aced the test because when I got results back, the test scores come back as an average of the students in your class. He was the only one who took the BC test. He got 108 out of 100. He didn't ask me one question ever. Just did it all year long because it was the first year I gave this class. It was the very first year I taught it. Every test I gave all year long, he would be the first one to turn his test in, and then I used his test to correct my key.
Oh,
Every one of them. He was crazy smart. Yep, that's the scariest smart kid I ever had.
That is kind of scary now.
He got accepted to go to Caltech in California, and they told him that his AA degree that he graduated from high school with, because he also got an associate's degree done at Hawaii Community College. They told him at Caltech that his associate's degree wasn't worth anything. He had to start as a freshman there. It's a pretty exclusive school. Doesn't matter what you do beforehand. He's like, well, I don't want to be in school for 4 more years. So he said, screw it. Then he went to the University of Washington. He dropped down after like a quarter, started a business with somebody else, made millions of dollars. He's retired now at like age 35. So he goes to Costa Rica now for fun on fishing trips all the time. And he's like a guy who takes people to Central America on fishing trips for fun. what he does for a living. Yeah, he bad. He bad. Stephen Madison, he was stupid smart.
Sounds like it, like graduated from here, that person name.
We've had a couple.
It's really weird to think about, like, small town and school.
It's tiny. But, you know, it's, to me, it's just this. I see this everywhere in life now. I mean, I see this everywhere. So if there are 1,000 people, that means there's 10 people up here in the top 1% of IQ. And there's probably 10 people down here in the bottom. It's just the way things are distributed when it comes to things like that.
Be quiet.
Like, actually, not weight. Oddly enough, the weight of all things is not normally distributed. It's usually figured out. It's gonna show up in your home. Hey, we need to move on. Are we good to go?
Yes.
Did you get the last one answered, ma'am? Did you see? I left that up here for you so you can see. It's 5,078 is how big the largest dragon is. It's about 70. Depends on where you round your decimal over here. If you don't round this the same as me, you'll get a little bit of a different answer. Okay? All right, folks, here, this piece of paper today says assessing normality. We're going to talk about what that means. What is normal? We're going to start with a big pile of data. This pile of data right here has to do with refrigerators. I don't call them refrigerator freezers. I think that's too long, so I just call them refrigerators. Okay, get this out of the refrigerator, would you? The measurements listed below describe the usable capacity of cubic feet. A sample of 36 side-by-side refrigerators. This comes from Consumer Reports back in 2010. Are the data close to normal? If I graph out all this data, does it fit the idea of a normal bell curve? Is it close enough? No data is ever perfect, but if it's close enough to going, yes, that looks pretty normal, I could do normal calculations with it, right? I can define Z-force, percentiles, and for the normal distribution. There are three things you have to check in order to say, yes, approximately normal. Number one, is it bell-shaped? Number two, does it fit the empirical rule? Ooh, do you remember the empirical rule? That is for 1, 2, and 3 standard deviations. What percent of the data falls within 1, 2, and 3 standard deviations? That's 68, 95, 99.7. Do the data approximately fall into those buckets? And then last one, what we do is we check what's called the normal plot. There are three different things we check. And when we look at the normal plot, which is something we will do in the calculator, is it straight? And so it'll be a calculator feature, will show you how to do this. All right. For the first one, to say that it's bell-shaped, what you're going to want to do is make a quick dot plot of your data. Okay? Quick plot, dot plot of the data. I'm going to just come right down here and go just like this. Whee! Make an axis. Let's see, top number, bottom number, it goes from about 13 up to about 18, 19. I guess I could go from 10 to 20. Would 10 to 20 work nice? And so I'm looking for easy numbers to chop in half. Actually, 8s are always really good. You know why I like number 8? Because I can cut the number 8 down to 4 and a 2 into 1 by chopping it in half easily, right? So if I do, if I just go 10 to 18 like this on my graphs, it makes it easy to chop in half. Halfway between 10 and 18 is 14. Halfway there is 12, and halfway there is 16. Like if I'm graphing something, you know, in the middle 10s from 10 to 100, I choose 0 and 80, you know, because multiples of 8 are nice to chop. That makes that 11, that's 13, that's 15, that's 17. I can go one more, make this 19. I gotta give it a label. These are fridge, and its capacity. Alrighty, I gotta start making dots. 12.9, 13.7, 14.1, 14.2, 14 and a half, 14.6, 14.7, 15.1, 15.2, 15.3. Boy, I feel like I'm playing cricket suddenly. There's 4 15.3s. This is just another repeat there today. There were 2 14 and a half. So that would be there. Okay, after the 15.3s, we got a 5, 6, 6, 15, 8, 16, 16, and another 16, two 16.2s, 16.3, 16.4, 16.5, 16.666. Oh, that sounds ominous. 16.8, two 17s, 17, 17, 18. Just have to be approximate. Doesn't have to be perfect. All right, important question number 1. Does it feel like this might be bell curvish? Higher in the middle, lower in the sides, most of the data in the middle, some strung out on the far left, far right. And I goes, yes. Dana, what do you vote? Bell curvy or not bell curvy? I feel kind of bell curvy. It's not a lot of dots. And this is the way reality works. Real life. 5 years from now, you're collecting data on something. This is real data. It's going to be dirty. It's never going to fit like you want it to all the time. It's just going to be approximate. And so I'm going to go over here. I'm going to go, yeah, I think this works. So I'm going to go check. It's kind of bell curvy. Kind of bell curvy. Doesn't have to be perfect. It might be. Step number 2, we're going to work the empirical rule here. What we're going to have to do is we're going to take all this data and we're going to find the mean and standard deviation of it. We're going to need the mean and we're going to need the standard deviation. Need those numbers. That means I got to take all the data and type it into my calculator. Oh my gosh, do I have it in there? No, yours. Maybe I type it into this one. I'm going to totally cheat. Will you think poorly of me if I already have it all pre-typed in? Can I save you a minute and go ahead and get you these 2 numbers? Oh, you're going to need to type it in anyway. Shoot. Oh, well, type it in. There should be 36 of these for frigid users. Yep, 36. After you get them typed in, you can do a 1 variable stat.
I forgot I got that well.
You need a copy of it? I got extra here.
They got right down on it.
What's that?
They got right on it.
Yeah, they're yours to keep. I got extras. You just dig it out here, boss. Here you go. We're right. You're going to take this data, put it into L1. What's that? I'm not sure what you're asking. For this problem we're working on? When you're calculating the z-scores, if you're taking a percentile and turning it into a z-score, then you use it for sum.
He's asking where to put the numbers, right?
Oh, where to put the numbers? Are you talking about this problem or over here? On this, we're just assessing normality. Does this fit a bell curve? Okay, we're not going to use inverse norm percentile at all here. We're just going to type this data into L1. Okay, it's going to be a long string of numbers. It's a race. I want to go be first. I lost yesterday. I felt like such a loser. I don't think Stan was the winner. What's that? 36. If you end up at 35, it's not good. Or 37, that's not good either. Just go back and find out what you're missing or if you have. It's always a good idea. And you're typing them in to double check. Just lazy, good head and shape. What's that? No, that makes it worse. Because then you put stubble and stuff in it. It rubs up against it. It's worse. It's dumb, 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 dumb. I wore my soccer today, and I don't have any soccer players. I'll wear it on Monday. The Marine girls are playing Oak Harbor on Monday.
It's not here, is it? It should be down. The Monday game is here?
Saturday.
Because Monday, I think I have to go 2 up.
Oh.
So, Gallon been dating for a couple of years with $2, it's like real cover. So I'll go to that one instead. From what I understand, Brady's doesn't really have a varsity girls soccer team this year. So, do you play soccer? I didn't know that. Okay, I understand. I get it. I did that my freshman year in college. Did that my freshman year in college on basketball team.
Your means,
Well, they had 2 guys get hurt on the basketball team, couldn't play, and they needed somebody else, so they got me. I like going to practice every day, it was lots. It was a little over my head in terms of talent. Yeah, totally. But I got to play some. But I like going to practice every day, that was lots. Those guys are awesome. Of course. Hey, we got David typed in. Did you get a mean standard deviation already?
yes, I can.
Alrighty, here's the deal. What we're gonna do is we're gonna draw some lines on here to represent the buckets of standard deviation. 15.825 is supposed to be my mean, so let's see, this dot right here with 15.8, that means the mean is right in there. Mean. So you want to draw a line there. And then you have to go a standard deviation above it, and standard deviation below it. So, standard deviation above, 15.825 plus my standard deviation 1.217, 17.04. Let's see, what goes, the 17s, there's 2 of them. They go in the first bucket, right like that. Now, how far do I have to go over? Let's see, I'm going to take that and just turn my plus into a subtract. 14.608. So 14.6. Did I have a 14.6? That one's a 14.608 is right above it. That's right there. There's one standard deviation. Let's see, where can I fit my calculations? I'll do them over on the slide over here. Plus or minus 1 standard deviation. There's 36 of these dudes. How many are inside of there? It's actually probably easier to count the ones not in there. It's subtract from 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 13, so that means there's 23 in there. We buy that 23 in there? 23 out of 36. What is 23 out of 36? 63.9%. Then we have to do the same thing for plus or minus 2 standard deviations. That'll be something out of 36. All right. Got to go another standard deviation below. So take this number plus 1.217, 18.259. Right there. And then let's see, we need the 14.608 minus 1.217. 13.391, 13.4, do I have 13.4? Nope. Just like that. There's 2 standard deviations. All of them but 2. That's 24 out of 36. I don't know what 24 out of 36 is. That's not right. 34 out of 36. Oops. Always nice when you make a mistake and you realize you made a mistake. 94.4%.
So far, how are we doing? Is this in the ballpark of 68? It was 68, right? Ballpark of 68, it's off by about 4. Is this in the ballpark of 95?
Yes.
Not bad. When you go out to 3 standard deviations, can you see that it's not gonna matter, it's all of them? That happens quite often. That will be 36 out of 36, which is 100%. And 100% is pretty close to 99.7. So you have to make a judgment. Are we in the ballpark of those numbers? I'm gonna say yes. That's pretty close. It follows the empirical rule, not bad. Okay, the last one, you're gonna thank yourself for having typed in all the data. The last one is called the normal probability plot. And the way you find the normal probability plot is, first of all, start off at the home screen. From the home screen, we're gonna go to what's called the stat plotter over here. Second, stat plot. You'll want to go into the first stat plot. It's actually worth noting. These should all be off except maybe the first one. You can have the first one turned on, that's great. But you want to go into the first stat plot and turn it on. The normal probability plot is the last one right here. It might be a straight row, but it's one that looks like a straight line right there. That's called the normal probability plot. It's the last one, not the histogram. Histogram's the third one.
Oh, okay.
And then there's 2 box and whisker ones, and the last one's called the normal probability plot. Make sure that you've got L1 chosen right here. Your data axis should be X, and you can use any one of these symbols you like. So you can use the little square. I kind of like the little square. Gives me a warm fuzzy. To zoom your data just to what's in the stat plotter, you can not graph, because graph takes forever. You can do this. Under the zoom menu, choose number 9. It's called zoom stat. Zoom 9. Worth writing down over here, because you'll forget it. Zoom 9. When you choose zoom 9, this is my normal probability plot. The normal probability plot is the z-scores for every one of these data points. You get a z-score, and you get a z-score, and you get a z-score. The z-score for that 12.9 is right there. There's the z-score for the 13.7. There it is for the 14.1, 14.2, and so on. These are all the z-scores for all these data. When you graph the z-scores, do they look like they make a straight line? Do they look straight? Yes, ma'am. Question?
Are you famous making it says quit?
It says quit or error?
Yeah.
Do you have a go-to?
What?
Does it say quit or go-to?
Yeah.
Hit the go-to. When you hit go-to, where does it go to?
Quit. Error memory, quit.
Memory? I don't think I know what that is.
No.
Oh, give me just a second here. Let me write this down.
Okay.
This normal probability plot is this graph of all the z-scores. If the z-scores are straight, so when looking at a normal probability, how can you determine if the distribution is constant or normal? It's straight. That looks pretty darn straight. Therefore, this is approximately normal data. I would say yes. My opinion, this data looks like bell shape. It fairly well fits the empirical rule and the normal probability plot. Just looking at that, that is total straight line. Okay, total straight line. To go along with this, it says sketch normal probability plot for distribution that's strongly skewed left. The best way to do this is make something that's skewed left and then look at what the normal probability plot would look like. So let's just make up some data. I like making up data. I'm going to start at 0 and go up to 10. And I'm going to put dots on here. Let's see. So there's 5, 1, 2, 3, 4, 7, 8, 9. So I want it to be skewed to the left. I want the tail over here. I'm going to put a data point there. I'm going to put a data point there. I think I'll put 2 points there. Although it's getting skewed. Getting pretty skewy. What do you think? Does that look pretty skewy? I think I'll put another one on 5 just to make it feel a little better. Now it's really skewy, right? It feels kind of nice, actually. I I can see this nice, just like that. I'm gonna take this data, put it into my calculator. I think I'll put it into L2. So the actual data, if I want to write all the numbers, I have a 0, I have a 2, I've got 2 4s, I've got 2 5s, 1, 2, 3 6s, 1, 2, 3, 4 7s, 1, 2, 3, 4, 5 8s, I'm going to put 4 9s and 3 10s. I'm going to put all of this into L2 and look at the normal probability plot and see if it makes sense after I observe it. Okay. Stat, edit. I'm going to go over to L2 and I'm going to type this in. 0, 2, 4, 5, 5, 6, 6. That's twice today. I said 6, 6, 6. If I were you, I'd be scared. Especially if it's the Antichrist. Math is the devil. I got 25 different numbers there. All I'm going to do is go back to my normal probability plot, the stat plotter, and change it from L1 to L2 and see what it looks like. Here's my, let's see, where's L2? Right there, data list, L2. When I do a zoom 9 on this, does that look straight to you? Or does it look like a hockey stick? It's totally curved. This is skewed to the left data because there's a bunch of data piled on top of each other right over here. So the z-scores curl up. So how can I do this? Here's my plus, here's my minus. It kind of goes like this. See how it curves up, or there's just a pile of data over here? That's what skewed data will look like in the normal plot. It's not very bell curvy. If it's bell curvy, it'll be totally straight. We like straight. So it's just one other way to assess normality, which brings up the question again, what is normal anyway? I'll tell you what normal is. Putting the toilet paper roll so that the paper comes over the top, not underneath. If you put it on backwards, you are abnormal and weird and not to be trusted in any way. You agree with me on this, right? Yeah, for some people that are obsessive compulsive, have we ever heard of OCD? I'm not OCD. I'm CDO. You know what CDO is? A CDO is when you're so OCD that you have to put it in the proper alphabetical order. Yes, I'm CDO. So, yeah, compulsive disorder, or obsessive, something like that. Hey, that's all we have for today. This problem right here on the back, right? This dude is a really good example to follow when you're doing the last homework for this week. I think it's number 18. Exact same kind of problem. Here's a kind of is it approximately normal? Okay, you need a calculator help, right?
Yeah.
Let me help you out.
Okay. So I don't know if Mr. already did it last year.
You did.
I don't know if he like updated it and then
Okay, so you got all that data back then. Okay, you need this other data over here. Okay, we're gonna go like this. Okay, this is really painful.
Yeah.
36. All right, when we go to your stat plotter, I can see that you have it turned on. You got a normal probability. Mark. Okay, that syntax error, I can tell you exactly what it is. I just saw it. In Y1, you have a bunch of random crap. Did you see it there?
Yeah.
In Y1, you have a bunch of random crap. Oh my God, it's like it's wanting to graph it.
I don't know how it got there.
It's like it's trying to graph it automatically.
Yeah.
So how do we wipe out your Y1 column? Oh my God, that's so crazy. I don't know how it got in there. You know what I could do? Do you have anything special saved in this calculator that you don't want to lose?
That's about it. But I mean, if it can't stay, then it's not a big deal. It's old. My sister had it when she was in high school and she graduated in 2011. And she probably got it like a few years before she graduated, so it's been through a while. You can do whatever you need to do.
I think I can just wipe out your y variables. So I can go into the memory management and I come down to y variables. And you can see that says 17 right there. I think I got it to work. Yes, perfect. Now, I wiped out all your data. And any programs you had are gone.
Right.
Was that where your games were?
They were in apps
So it looks like they're still there.
and then P. I did literally the box game is the only one I play, and it's a big.
Okay, we'll make sure it's still
Right, it's still there. I'm pretty sure it's like part of the calculator.
there. Yeah. So, but it should work now. So, exit. It's trying to exit. Are we exiting? Exit. Enter. Okay.
Weird. Can you turn it off? I don't know what it's doing something. That works. Not worth it with the phone.
It's the reset button. I thought that was the reset button. Somebody needs something from me over there?
Was to the restroom?
Of course, yeah. Fine. Don't ask me that. Just go.
Oh, no, I didn't know.
I didn't know. Anyway, I took care of the y equals problem. Okay, so this is back to memory. Okay, so if I do this, if I go stat, well, first of all, let's go to mode and make sure you're in degrees mode because that's the killer of all things. Stat, edit, there's nothing there. 1, 2, 2, 3. Okay, so there's some data, right? If I go to the stat plotter and then turn the stat plotter on, and then come down here, whoops, normal probability plot, L1, zoom, 9, or
Perfect.
there's the z-scores for the lines put in.
Awesome.
So they make kind of a straight line. Oh, it works.
Awesome.
Oh, give me 5, 2 minutes.
Without stopping, so it doesn't matter the time, so I can like, because I could run a mile in 9.
Run a mile.
9. I like running. I want to do it for exercise. I don't like to work.
No.
I'd rather, I have more motivation, just like, okay, I'm gonna go for a run, than like, I gotta go work out.
I like running after a workout.
No, I don't even work out, I just run. I don't like working out.
She goes on a treadmill.
I don't like weights,
So I just
since
run.
they're too heavy.
I have no balance. I don't really, so I just run. I just run.
Okay, we have 4 people, my computer's back there still running.
Yeah.
And it's laughing at us. How do I look at my shirt and I'm black today? I got told that if I'm gonna wear this